Hi everyone. I'd like to welcome you to Math 344 Linear Analysis 2. My name is Dr. Ryan Tully-Doyle, and I'm very excited to be leading you through this class. This is some of my favorite math that exists, and I'm really interested in the content and in helping you guys to grapple with what is going to turn out to be the language that all of modern science and engineering is built out of. So, to tell you a little bit about myself, I did my undergraduate degree here at Cal Poly in the math department. I did my PhD in San Diego, and then I left California and I traveled all over the country for 10 years before I got a job back here. So I'm in my second quarter at Cal Poly. It's very exciting to be back, although I have to say it would be more exciting if I actually got to work on campus. The purpose of this introductory video is to sort of walk you guys through how the course is going to run and what the different materials look like, and hopefully to give you a taste of how the lectures for this class are going to go. Every week you're going to get 2 or 3 videos to watch, like this one, that cover some specific topic related to a chapter in the textbook that we're working out of in that particular section. As part of that asynchronous component, you'll complete homework assignments, which you won't turn in, but on a weekly basis there'll be a quiz that you take that pulls problems directly from the homework. And then every 3 or 4 weeks there'll be an exam, and then a final that's cumulative at the end, just like usual. The synchronous part of the course is a live office hour component, and I would encourage you to attend the live office hours because that's where you're going to get what feels like a synchronous course. Students come and ask questions. I go over ideas that need more clarification in the lectures. It's actually very useful for me to get feedback from students on how the course is going, and I get that in office hours as well. And it makes it feel a lot less like we're sitting on opposite ends of YouTube as far as this class goes. So if I get to interact with people, that makes the class much more exciting. To give you an idea of how the math itself is going to work, as we go through the course, we're going to see things like different ideas that I'll be talking about. And just like on a blackboard, I'm going to write mathematics. So you might have a piece of mathematics that looks like the sum of an converges if the limit of partial sums, that is, the limit as n goes to infinity of the sum from n equals 1 to infinity of an, exists and is finite. Now, sometimes my big head might be in the way, and so I can get myself out of the way. But the idea here is that as we do the course, I'm going to be on camera talking to you guys so that you can see my face while you're either listening or reading the transcript that I'll provide for these videos. The nice thing about doing it this way is that when I'm done, I can take the chalkboards that I've created in the course of making these lectures and post those as well. So every video will come with a set of lecture notes that I've created while making the lecture. So you can print those out ahead of time or download them so that you can follow along as we go through the lecture. I'd also like to show you something about the way that the structure of the course is arranged in terms of the resources available. So the Canvas course for this page looks pretty typical, like this. The way I like to arrange my courses is by modules. So if you click on the module page, what you're going to see is that there are 3 units in the course corresponding to the different pieces that we're going to cover. And then week by week, what will happen is I will post a page or publish a page inside each one of these modules corresponding to that week's content. Inside each page, there's going to be a video. There will be a transcript of the lecture. There will be a copy of the lecture notes that I made in the course of the video. A link to my online book, which I'll talk about in a second, will be there as well. And also exercises for that particular assignment. The exercises won't be collected, but they are the content which I will pull from when I make the quizzes. So another thing that's important is what the textbooks for the course are. If you look at course resources inside of the dashboard, you'll get pointed to the bookstore. The book that we're using is called Differential Equations in Linear Algebra by Annan and Good. It's my impression that this is the book that most people use in Linear Analysis 1, so I try to choose a book that people were already using so you wouldn't have to buy a new one. The second book for the course is by Brad Osgood, and it's called The Fourier Transform and Its Applications. That's a free set of lecture notes. There is a textbook you can buy as well, but I would recommend that you follow the link to the free lecture notes. And we're only going to be working through pieces of the first 3 chapters of that book. And then we're going to go back to the Good and Annan book for the third part of the course. So we're going to start with chapter 11 in Good and Annan. We're going to move to the Osgood chapter 1 through 3, and then we're going to go back to the textbook again. Supporting all of that, I've written my own sort of notes/book that hopefully will turn into a real book so that I can provide this in the future for students for free. And you can find that also linked. So I've created all of these. These are sort of guiding the way that I want to work through the course. There are no exercises here right now. The exercises can be contained in the Ann and a Good textbook. For the Osgood stuff, I will write my own exercises and provide those. But if you go here, you can get basically a stitching together of all the different resources in the class, but in one place. And this is also nice because it's accessible by phone. All of the ideas that I really think are important are here. I've also added perspectives of my own that I think are really important, like the linear algebra differential equations blend that is the core of all of this. If you get in my book and you start clicking around, you'll notice that it's not finished. So for example, if you go to questions of convergence, there's nothing here. I'm going to be writing this as the course goes on so that I'm always ahead of where the class is. So that if you want to work ahead, you can work ahead. And if you want to follow my perspective, you can. The nice thing about the platform that I've chosen to write this in is that I can embed code. So the language I've used here is called Sage. It's a mathematical programming language. And that means that because this class is so computation heavy and so graphic heavy, to really understand what's going on, I can create plots on the fly. And I would encourage you, when you see a box inside this textbook, that you click on the Evaluate Sage cell so you can actually see the graphs that are being produced. Okay, finally, and this is important for keeping yourself organized in the course, if you go to the syllabus page inside the course and you scroll down to the bottom, you're going to find a Google Calendar that sort of lays out what my schedule for the course actually looks like. So you'll know where you need to be and where you don't need to be by looking at this. So this is in the syllabus, but you can actually click through it onto view it on Google. You can add it to your own calendar if you want to. But this is sort of my plan for how I'm going to attack the material in this course. Okay, I've tried to keep it so that I've got basically 2 lectures worth of stuff per week. Sometimes those lectures might be a little longer, sometimes a little shorter, depending on what I want to cover, but weekly quizzes and punctuated by exams. All the links to various things will be posted in here. The textbook links are here, so the Osgood and the link to my book as well. I don't have a link to the Ann and Good textbook here because I don't know if such a link exists, and if it did, it would be illegal. The way that we're going to be submitting assignments in this class is going to be through a program called Gradescope. So you've already gotten an email sent from Gradescope to your Cal Poly account indicating that you've been enrolled in my course in Gradescope. Now the reason we're using that and not the Canvas uploading system is I have 100 quizzes to grade weekly. It's much easier in Gradescope than it is in Canvas. I like to give feedback when I grade quizzes, and the best way to give feedback is to use something where I can use the tablet that I used to write on the screen, but in a grading context. And the Gradescope interface is far superior to the Canvas interface for that. So if you go to Gradescope, gradescope.com, you can create an account there. It's secure. It's used at dozens of campuses, if not hundreds. Cal Poly doesn't have an institutional license, and so you can't log in through Canvas, but hopefully we'll have that in the future at some point. The idea here is this is just a upload and grading system that's easier for both me and for you. And that is going to be how we're going to be doing our submissions, is PDF files uploaded to assignments here. I'm going to create a walkthrough video that's going to show how to create a PDF and upload it when we get to the point of the first quiz. There'll be a little bit of lenience around technical issues for the first couple of weeks of the course, but I'm going to be a lot less patient with that as we go on because hopefully people figure out how to do it. The nice thing about Gradescope is that they have a lot of support for students. So if you have questions about things, you can get on their documents and it'll actually walk you through how to do the various submissions step by step. And there are videos here as well. Another resource that I'd like to point out in Canvas is the various ways to interact with me here. One of the things I intend to do is to be active in the discussions tab. So if you have questions that you would like to have answered, you can ask them here. There's also a chat feature. I've never had a student use it, but you can feel free to chat in here if you've got questions as well. Please feel free to introduce yourselves to me. I'd love to know who you are. Like I said, it's not quite the same teaching on the other side of a camera. So the more I get to know about you, the more I feel like I'm actually engaged with you as students and people. I should finish by saying that my philosophy for this course is to provide you guys with all the materials that you need to succeed. So what I mean by that is you're going to have my lecture notes. You're going to have my supporting notes that I've written up for the book that I wrote. You're going to have your textbooks. You're going to have all of the quizzes and homework that are going to be the bank of questions that I pull from when I construct the exams. They might not be literal, but they're going to be very similar. You shouldn't expect this course to be a gotcha course. At the same time, this course is full of new mathematics. The stuff that you're going to see here is stuff that you may have seen if you've taken upper division engineering classes, but from a mathematical perspective, there's a unifying language. That's what linear algebra does here, is it provides a unifying language for all of the ways that scientists, engineers, physicists, and mathematicians approach the analysis of functions. So the course is challenging, but it's also the core of how modern scientific investigation works if you're going to use math. So this is a second course in a sequence, and I know that for some people it's been a while since you took Linear Analysis 1, or you're worried that the Linear Analysis 1 that you had is not going to usefully inform what's going on in Linear Analysis 2. If you need to review any of those ideas, I've made a list of some things that you might want to look at in my textbook. And you can see here that I've kind of pulled some ideas from calculus, differential equations, and linear algebra that are going to come up in here. And of all of them, probably the most important out the gate is the idea of the infinite series and the power series in particular. The first 2/3 of the course are going to depend heavily on the idea of series of functions. So if you haven't seen that, or if your calculus professor got to the end of the quarter and just didn't have time to stuff it in, then go back and start looking at power series. So we're going to get out the gate with an introduction to power series, but it assumes that you've got some level of comfort with them as well. It's more a review and less of a lesson that you're learning it for the first time. Because this course is so dependent on ideas that you've seen in earlier classes, if you come across an idea that you do not understand, haven't seen before, or would like more clarity on, please let me know by email or in office hours so that I can create some sort of supplement if lots of students have that question. Because if you have a question, probably lots of people have it. That's it for the introduction. Hopefully I look forward to being able to see you guys in person sometime. At the very least, I'll be able to see you on Zoom if you come to my office hours. Please come to my office hours. It gets lonely in there. And good luck starting the course.